In today's math lesson, we're going to talk about describing distributions and look at some examples. So we have a symmetric distribution, and a symmetric distribution is a type of distribution where the left side of a distribution mirrors the right side. A symmetric distribution is never skewed, meaning it doesn't lean to the left, lean to the right. A normal distribution is symmetric, and it's also what's called unimodal, meaning it has one peak. And this happens very often when you have a super large data set where you have what looks like a bell curve. And a bell curve, like for the SAT, where millions of people take it, you end up with mean, median, and mode all in the center, and you have this nice symmetric shape where it looks like if it flipped over this line, the left side would mirror the right side. It would be symmetric, meaning it stacks up about equal on the left and equal on the right. Now, skewed left, a distribution is called skewed left if, as the data displayed above, the left tail is much longer than the right. Note that in skewed left distribution, the bulk of the observations, medium large, with a few observations that are smaller than the rest. So we're kind of looking to which way is it tailing. So if we look up at this line plot looks like it's tailing to the left. This histogram, we have the bulk of the data on the right side, but it's tailing to the left. So these are both called skewed left. And skewed right would be the opposite. So for skewed distributions, it's quite common to have one tail of the distribution considerably longer or drawn out relative to the other tail. A skewed right distribution is one in which the tail is on the right side. A skewed left, the distribution, the tail is on the left side. So if we look at this line plot, our data is tailing to the right. This histogram, the data is tailing to the right. So we're kind of looking for where the tail is. Where's it trickling to? Lesser and lesser points to the right. Lesser and lesser points to the right would be skewed to the right. All right, we have a line plot here of red widgets, and we were looking for the range. So to find the range, we want to take our highest point and subtract the lowest point. So it looks like we have data at 38 for the highest point, data at 15 for the lowest point. Subtract those, get a range of 23. What's the median? Well, we could count up the number of data points and find the one or two in the middle. And if we have two in the middle, add them up, divide by 2. In this case, I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we're looking for the numbers that are like 8 in. We're looking for the middle of the data. And if we listed those out, we would see that we have a median at 35. And that's probably the best way to do it, is list all your data from smallest to largest, and then you can find your number in the middle for your median. Remember, if there's two numbers in the middle, you would add them up, divide by 2. Now, does this data show an outlier? So an outlier, we're looking for a data point that is much larger or much smaller than the rest. And this one has, way out here on this end, is 15. There's no other points anywhere near it. So we would say, yes, there is an outlier. It is 15. All right, can you guys identify the shape of this distribution? We have a histogram. Is it skewed right, skewed left, or is it roughly symmetric? And not exactly symmetric, but roughly symmetric. We see we can have a little bit of variation, but roughly looking like a bell curve, looking like our normal distribution. It looks roughly like we have the same amount of data on the left or right. We would say that is roughly symmetric. How about this one? Identify the shape of the distribution. Is it skewed to the right, skewed to the left, or roughly symmetric? And we're looking for where that tail is. All right, so if I'm looking for the tail, it's coming this way, getting lesser and lesser that way. So we would say this is skewed to the right. All right, you guys try this one. Is this line plot skewed to the right, skewed to the left, or is it roughly symmetric? Well, I see this highest point stacked up here, and it's normally an indication that it's not where the most data is stacked, it's where it's trending to, we're trickling towards. So it looks like we're tailing to the left, so we would say skewed to the left. All right, I want you guys to go ahead, and we have this line plot of bunnies. Find the range, find the median, find the outlier, and pause the video, find those, and come back, and we'll see how you did. Well, welcome back, everybody. If I take my greatest point and my least point, I'm subtracting 37 from 25 and getting a range of 12. And if I list my numbers from smallest to largest, looking for that median, my median is at 33. And is there an outlier? Is there a point that is much higher or much smaller than the rest of the data? And in this case, they're all clustered really close together. So in this case, no outlier. And I hope that helps you guys figuring out if you have left skewed, right skewed, or roughly symmetric data, and that you can find things like median and range. Have a great day. OUT spells out.